Another common thing to do in equilibrium is calculating Kp. Kc we know has to do with concentrations, but Kp has to do with pressure. Since a lot of these calculations are involving gases, we can actually use Kp, which is the pressure constant, instead of the concentration constant. The setup is the same. Okay, so for example, let's take the first equation. Write the Kp expression for the following equations. All right, so here is the first equation, which is PCl3 plus Cl2 to give PCl5, and so the Kp expression for this is going to be the pressure of PCl5 divided by the pressure of PCl3, and I'm just going to put it in brackets so that we don't get confused, and then the pressure of Cl2. Now there were no coefficients over here, so we don't have to worry about the coefficients. Okay, it's just 1 and 1 for everything. The next equation is oxygen plus 2H2 to give us water, as in gas. Excuse me, I think this is supposed to be liquid, my bad, there. So then the Kp expression here is only going to be for gases. Remember, we don't take liquids or solids in the Kc or Kp expression. So there is no product, which means we can write 1 for that. And then the reactants are oxygen, so pressure of oxygen, and there is no coefficient there, so that's just 1. And then pressure of hydrogen, and the coefficient here is 2, so we have to raise it to the power of 2. So essentially it's the same, okay, as for Kc, except that you are using pressure. You don't have to use square brackets, you can use just the normal round brackets or parentheses. Okay, one little thing over here regarding calculation of Kp and Kc. So calculation of Kp is equal to, from the calculation of Kc, RT to the power of delta N, okay, where delta N is equal to products minus reactants. So you can convert any Kc value to a Kp value. The only thing you have to do then is use the gas constant and temperature in order to make those changes. And then of course you need the delta N, which is the coefficients, okay, over here. The way we get just the Kc times the RT value is by using the gas law, which is PV is equal to nRT. And remember then, pressure is equal to nRT over V. So N over V, moles over volume, that is going to be molarity. Okay, so if that is molarity, then that is our concentration, and so that is going to come in the Kc. The R and T are going to be the same for all the gases because you're doing the reaction at the same temperature, and of course R is the gas constant. Okay, so you don't have to worry about changing those two values. That's why we can use them right here in this equation. And then T is the temperature in Kelvin. Okay, don't forget that. So you have to make the conversion there. So that is how we convert Kp or Kc into Kp or Kp into Kc, however you want to do this. So let's do a problem over here. What is the Kp of N2O4 to give 2NO2, and the Kc value is given to us 4.63 times 10 to the negative 3 at 25 degrees Celsius. Now remember, the temperature is important for us when we are dealing with Kp because of our equation. Okay, and so temperature, convert that right away to Kelvin. So this is 298 Kelvin. Delta N is going to be, remember, the moles of products minus reactants. And so this is 2 minus 1, so that is 1. We need that for the power. So then Kp is equal to Kc RT delta N, which is 4.63 times 10 to the negative 3, 0.0821 times 298, and all of this is raised to the power of 1. And right now, I mean, 1 doesn't matter to us, but I think it's important to write it so you understand that you can't ignore the delta N. Okay, it has to be there. So then your answer is 0.113. That's your final answer for this. Kp, just like Kc, also has no units. So okay, the third problem, okay, then is calculate the Kp of N2 plus 3H2, hydrogen plus nitrogen to give ammonia, very common reaction. and the Kc is 2.3 times 10 to the negative 3 at 375. Okay, and we're supposed to calculate Kp. Again, temperature 375 plus 273, that's 648, and delta N now is 2 minus 4, which is equal to minus 2. Minus 2 meaning that we have to inverse something and then we have to square something. Okay, and so Kp is equal to Kc RT delta N. I always write writing the equation again so that we know what equations we are using, and it will be really nice if you return the favor to me. Okay, so when you do this problem in your exams or homeworks, please go ahead and write the equation that you're using. It's really helpful for you also and for me also. So 648 to the power of negative 2. Power of negative 2 really means 1 over, and then whatever you have squared. Okay, and so that is 8.13 times 10 to the negative 6. All right, although I think in your fancy schmancy calculators you should be able to do the negative 2 without really understanding what it means, although this is what it means. Okay, 1 over the square of the number. Okay, anyhow, that's how we calculate Kp from Kc.